Morning, everyone. Get started in just a minute or two. Morning, folks. We'll get started in just a couple of minutes. Alrighty, I think we'll get started now. So today's going to be kind of like a bit of a work period. So make sure you got your pencils handy and you're ready to do some work. Here's what I'm going to do is I'm going to give you a few questions and I'm going to get us to work on them throughout the period. So if you want to be vocal in the chat and discuss the problem, you're welcome to. If you would prefer to just have a private conversation with one of your friends, maybe you could contact them like on like a text message or Instagram message or something like that. You're welcome either way to discuss these problems with whomever you like. So I'm going to start off with something fairly straightforward, so not too bad. So, oops, that's not what I wanted. I wanted this tool here. So here is my set of axes. And, okay. So I'm going to give you a point right over here. So this is the point -2, -2, 5. Okay, and so this point right over here is corresponds to the terminal point of the terminal side of this angle, this nice big angle here, right? So here's our initial side, there's our terminal side, this is our angle here. It goes all the way from here to there, a little bit past 90 degrees. Who knows what it truly is. So this is our angle. Let's call this angle alpha. I want us to find all three trig ratios of this, let's just call it of alpha, okay? So I'm going to give you 3 minutes. That's 1 minute per ratio. Although I think that one of the ratios will be straightforward to calculate. 2 of them might take a little bit longer. So I'll give you 3 minutes. And this is getting blocked. Let me just move this down below here. Okay, not that you necessarily need that information, right? Just find the 3 trig ratios. That's what you're asked. So find sine, cos, and tan of alpha. Go ahead, 3 minutes starting now. 2, 1, and time's up. Okay, so let's oops, that's not what I wanted to do. Oh, that's your assignment. Did you, by the way, did you guys get the solutions to that? Did I think I posted the solutions, right? Let me know if you did not get the solutions to the assignment. I'd intended on posting the assignment solutions. You know, it actually, I'm seeing it now. I don't think that I posted them. I'll post them right now. How do I do that again? I think I have to edit. There we go. You know, I'll do that later. There's no reason for me to do this in the middle of class. Yeah, I do not think that I gave you those solutions, so I'll have to do that another time. Okay, I wanted to cover this question here. This is a really good question. So what I want you to, oopsies. I want you to think about this one for a minute. So, so using different values of theta. So using different values of theta, so you're going to have to kind of come up with some of your own different angles. I want you to evaluate sine of theta and sine of negative theta. Okay, so sine of theta and sine of negative theta. I want you to then point out how do these values compare. Okay, so give yourself a minute to think about this one. So you might want to use a calculator, a scientific calculator that can calculate sine and cosine and all that. So give yourself a few different values of theta. I'm going to give you let's say 2 minutes to talk about or to think about this one. So yeah, think about how the different values of theta. You know, if you take the negative version of theta, what happens to your sine function? Okay, and then in a minute we're going to talk about y. We'll talk about y. Which questions? Like these questions? Yes. Or on the assignment? Okay, dokes. So let's think about what happens with these different values of sine theta, and I'm gonna spare us the actual calculations, and I'm just gonna take a look at our coordinate plane and what these values mean on the coordinate plane. So here's, come on, that's supposed to be a nice little circle. There we go. Look how beautiful that is. Okay, and I'm just going to move it up just a wee bit. Just want to center it. So there we go, And that looks pretty centered to me. Okay, so let's say I take a value alpha, like that. There's my value of alpha. And here is my terminal side right here, like that. So there's my terminal side. Then if I were to take negative alpha, and let's do this in a different color. Let's do green. So here's my negative. Oops, I want the actual pencil tool. Here we go. So let's say we go with negative green, and there is our negative alpha. So here is negative alpha. Here is positive alpha. Okay, so what happens to the different sign values? So remember, sine is going to be, so sine of alpha is going to be, well, it's going to be opposite over hypotenuse, right? So katoa. So we've got O over H. And well, the opposite side is the vertical side, right? So I'm hoping at this point we're developing our understanding that the vertical component here that's what our sine value represents, divided by the radius of our circle here, right? Divided by the hypotenuse. So that's kind of what's going on here, that we have like this vertical component. So if I take negative alpha, now instead of going up, I'm going down, right? So I'm going down. So the sine, if I have sine of negative alpha, then that's going to be like my opposite side is now negative. I've got opposite, negative opposite over hypotenuse. So we get this interesting little relationship that sine of negative theta is equal to the negative of sine of the positive theta. Isn't that neat? That's kind of the where is the assignment? I looked on the website and Google couldn't find it. You mean the assignment solutions? Yeah, I'm just realizing now that I did not upload the solutions. I will post them now. I'm sorry about that. Well, I'll post them after class because I actually have to export them from my iPad. I thought that I'd already done that. But just let me know on in the chat. Like, you did receive your grade, right? And also the corrections, right? Like I did mark up all of your assignments on my iPad with my pencil. I gave you check marks and wrote little comments and things like that. So if you were unable to access that, please let me know. I know that one student had some difficulties accessing that. But I emailed them, so I can email them, I can email your solutions or your corrections rather. But you should be able to access it on Google Classroom. So I'll post the solutions right after class. They're right here. You can take a look at them. I mean, we can go over them very quickly right now. So yeah, the first one, I think the biggest mistake that most people made was that they forgot the plus or minus, right? It's true that the square root of 16 is just 4. It's not plus or minus 4, it's just 4. But when you're solving for this, what am I trying to do? If x squared is equal to 16, well then x is equal to plus or minus the square root of 16, because you could have negatives in there, right? So because negative 4 squared is positive 4. Yes, that. Yeah, that's what I'm talking about. Okay, and then the other one that I think was a major issue. A lot of people seem to forget what a conjugate was and how to calculate the conjugate. So that was an issue. I think a lot of people got the last question right. I don't think there was any major issues there. Yeah, the radical equation caused some difficulty because there's just a lot of algebra. Oh yeah, and then the main thing that was like the main mistake that a lot of people were making was they were forgetting to check their answers. Now it turns out that both like all of the answers here turned out like they were good. They all worked out. However, you still have to check. If you don't check, then you cannot be certain that your answers work, because in radical equations there are often equations in here where the solutions don't work, even though you do all the correct algebra, but the solutions don't work. So so I did take off marks if you did not check your answer, because we did go through that several times in class together. So let's see here, 11 pre-cal. Oh no, grade 10 advanced. There we are. Okay. Anyway, yeah. So I'll post those solutions very shortly. Okay, I think we're gonna do the same thing that we just did. So I want to investigate this question again, except I want you to think about it in terms of cosine. Okay, so how does that affect cosine? Okay, so think about that for a second. Okay, so I'll give you what did I give you? 2 minutes for that one? I'll give you 2 minutes for this one too. Okay, so this time we're thinking about cosine. So we're going to kind of have a very similar argument here, but here, let me just erase all of this. So we're still gonna look at like this part is still good, right? We're still looking at positive alpha and negative alpha, or theta, or whichever angle you want to call it. So let's see what happens with cosine now that we're going in the opposite direction. So I know that cosine of alpha is going to be, well, this time it's adjacent over hypotenuse, right? So now it's not so much the vertical part, it's the horizontal part. It's this portion right here, right? So it's this portion right there. So and same with the cosine of negative alpha. It's still going to be adjacent over hypotenuse. Okay, and if you take a look at this, and here's the thing that's interesting, is that the radius here is still going to be the same. So our hypotenuse, the hypotenuse of our right triangle, is going to be the same in both cases, right? It's going to be the same in both cases. Now, here's what's interesting. Here's what's really neat. The adjacent side, it's shared. We have exactly the same adjacent side. So the adjacent side is the same. The radius or the hypotenuse is the same. So it turns out that cosine of negative alpha is equal to cosine of alpha. Doesn't matter if you take the positive or negative version of it. It's a really nifty little trick. So we have these two rules that kind of prevail in the world of trigonometry. So these are really interesting rules. So we have that sine of negative alpha is equal to negative sine alpha, and we have that cosine of negative alpha is equal to just regular cosine of alpha. Isn't that neat? So these are two rules that will come up, and what's interesting is that throughout the next couple of years, you're going to be learning lots and lots and lots of new rules with respect to trigonometry. So with trig, you have all these rules, and there's so many different little equations like this. And finally, in grade 12, what you'll be doing is you'll be doing these things called proving trig identities. Proving trig identities. And trig identities are basically where you're taking all of these different equations and you're using them bit by bit to sort of take one expression that has lots of trig functions in it, and you try to transform it into another one. And it's a fun one. It's challenging because there's so many little trig laws. So these are some trig laws. These are the first ones that we've seen, I think. That if you take the sine of a negative angle, it's the same thing as taking the negative sine of the positive angle. And that with cosine, it doesn't matter if your angle is positive or negative, you get the same ratio. So pretty neat. I mean, I think it's pretty neat. Okay, so we're gonna start off with a new topic now. We're gonna talk a little bit about oblique triangles. Oblique triangles. Okay, so oblique triangles, these are triangles that have no right angles. So we have triangles with no right angles. Okay, these are triangles that have no right angles. Okay, so can we use trig? Well, the answer is yes. Yes, we can use trig. The trigonometry is going to have to be just slightly adjusted, but yes, we can use sine, cosine, and tangent functions on our trig functions here. So yeah, let's talk about how we would do that. So I'm gonna talk about a oblique triangle. So this is what an oblique triangle looks like. You may say, oh, this looks like 90 degrees. It's not supposed to be. So maybe I'll make it a slightly different looking triangle that is not 90 degrees. So there. Now we can be sure none of these are right angles. So we have two. What am I trying to say? We've got three angles, none of which are right angles. Okay. So this would be our oblique triangle. So if we want to use any kind of trig, so if we want to use trig on an oblique triangle. So if we want to use trig on an oblique triangle, we have to know some properties of the triangle. Okay. So what are the properties that we're talking about? Well, we've got any triangle has three angles and 1, 2, 3 sides, right? So I've got 1, 2, 3 angles and 3 sides, right? Now, if I know all of those, then I know everything that there is to know about the triangle, right? Once you know all of the measurements in a triangle, then there's really not a whole lot left to calculate. But the idea that we're trying to get at is like, what if we only know one of the angles, but we know like the length of 2 of the sides? Do we know everything about the triangle then? Well, turns out yes. Yeah, we can learn a lot about the triangle, even if we only know a little bit about it. So one possibility is that we know, like what if we know 2 angles? Okay, if we know 2 angles, well, let's think about what we would have. So let's say I know one angle and then another angle. Okay, if I know one angle and another angle, well, if that's all I knew, well, I don't know anything about how long any of these are, right? So maybe like it's a really small triangle, maybe it's a really long triangle, right? I don't really know anything about the triangle. But if somehow I knew one of the side lengths, like maybe the side length between these 2 angles, then all of a sudden I know everything that there is to know. Oh shoot, hold on a second. I have a very important package coming to me. Hello. New iPhone. Haha. Got it on RBC Rewards. Got a free phone. Isn't that funny? All I had to do is spend thousands and thousands and thousands of dollars on my credit card, and they give me a new phone, man. Isn't capitalism great? Out of breath. I just ran up and down the stairs really quickly. Okay, so let's say if we know 2 of the angles and we know the side length between those 2 angles, then you can kind of imagine, well, now we know everything that there is to know about the triangle, right? Like we could construct the triangle, right? So, sorry, you can probably tell I'm a little out of shape. I'm not biking, you know. I used to bike to work every day, and maybe I need to go skateboarding or something. I'm totally out of shape. Point is, like if you knew the side length and those 2 angles, well then you could go and construct the triangle yourself, right? You could reconstruct the triangle, and then all of a sudden you know what that triangle is going to look like. So so what we would call this is that we would call, well, this, here's an angle, and here's the side between it. We would call this angle, side, angle. We know 2 of the angles, and we know the side between them. If that's the case, then we can construct the triangle completely. Okay? So, what I want you to think about now as the exit slip can you reconstruct a triangle if you know, let's say, angle, side? So that would be where you have, you know, one angle, you know another angle, and then you don't know the side the side length between the angles, but you know the side length over here. So you know where this is. Okay. So you know that one angle, you know another angle, and then you know the side beside one of the angles, but not between the 2. Okay. So so yeah, see if you can figure that one out. It's basically just a yes or no, a true or false. But the purpose of the exit slips is not to, you know, overwhelm you. I want you to think about this. So can you reconstruct a triangle if you know 2 two adjacent angles, so two angles, and then a side that's kind of on the outside. So think about that. So I'm gonna sort of end the lesson there. I want to talk a little bit about the project. So at some point in the next day or two, so either today or tomorrow, I will post a little document on Google Classroom that should help you get the it should help you sort of get an idea of how I'm going to be grading the final project and what kind of things I'm going to be looking for. So basically, what I want to see on the project is a deep understanding of several topics. So I don't want to just see one topic. I want to see several topics. I'm thinking probably 4 different topics. So if you can show me in any way that you can think of a way of demonstrating a deep understanding of 4 topics or more, then that's what I'm looking for. So basically, I'll have a rubric that will look something like this. And there will be 1, 2, 3, 4 columns to the rubric, and then 1, 2, 3, 4 rows. Or actually, I got those wrong. Rows and columns. Anyways, well, we'll have a 4x4 grid, and then on the columns will be topic 1, topic 2, topic 3, topic 4. Right. So those topics are your choice. Right. Those are your choice. And then on the side here, the way like on topic 1, like maybe this would be quadratics, right? Or sequences in series or something like that. We'll have, okay, so like did you have a show, like could you calculate, like, or could you give an example of a quadratic, like, right? That would be like a 1. Like maybe could you graph a quadratic? Like could you do that? Another one is like, could you do some cool things with the quadratic? Like could you make an interactive slider on Desmos or something that has a quadratic? That'd be like a 3 out of 4. A 4 out of 4 would be like a really deep understanding where you'd be able to draw connections to other topics, things like that. So it looks like, can you make a program for your project? Absolutely. Just keep in mind that like I don't want to have to compile a program. So like I'm not super interested in getting a big thing of source code in like C# or something, and then I have to go find a compiler for it or something. But yeah, if you can make a program that's been compiled for me, that would be great. The only time I would take like a source code is if it was in what do you call that? What is the programming language? Like Python is not a compiled language. It is a, what's the word I'm looking for? Not dynamic. Interpretive language. Yeah, it's an interpretive language. So like you have like a command line, and then your programs are just there. You don't actually have to compile them. So yeah, I mean, if you want to write a program, that would be super cool. But just make sure that it's fairly easy to share with me. Like I've been programming for about a decade now, so I do know my way around the command line, and I can compile certain programs, but I don't want to be like I don't want to be having to spend lots and lots of time trying to hunt down different compilers and that kind of thing. So just bear that in mind if you do want to do a programming project. Just make sure that it is easy to share with me. And as for homework, yeah, I'll post a little bit of homework in just a minute. I'm trying to post homework for all my classes right now, so I'm just getting a little distracted here. Yeah, here's my new phone though. I'm pretty excited about that. I don't know if it's inappropriate to do an unboxing in a math class, but here it is. This is the iPhone SE. It's pretty much exactly the same as my iPhone 8. But I got it because my wife, her phone is awful. Just the battery dies and it glitches out. There's scratches all over the screen. The screen is popping out. So I wanted to get this for her, but she didn't want to spend any money on a new phone. She said, "No, I don't like spending money on technology." So I said, "I do." So I got this for myself, and then she's gonna get this one. So she gets my hand-me-down. But yeah, they're pretty much exactly the same phone. So except this one is quite a bit faster. So yeah, I'll post the homework shortly. Yeah, if you ever have any questions about the material, don't hesitate to reach out, as always. And yeah, I'm gonna sign out now. I'll talk to you guys tomorrow. Have a good one. Bye bye.